Alright, geometry students, I thought I would post a video to help out with IXL standard N.14, proofs involving quadrilaterals part 2. So if you need some help with N.13, look back at that first video, and it's on the YouTube playlist. Just to make sure you understand, I've got these videos lining up in a playlist for you on YouTube. So if you go to YouTube, search Z Martin Math, or just click one of the videos I've sent out before. I've got a playlist building right here for you so you can see some of the standards I've already created videos for to help you out, to help you complete these IXL assignments. So let's take a look at N14. So we know that GI, segment GI, is congruent to segment FH. Complete the proof that angle FIH is congruent to angle GHI. So we've got a lot of stuff going on here. We know that segment GI is congruent to segment FH. And so we've got segment GI congruent to segment FH. And then we see some parallel lines here, parallel lines there, a lot of givens, and then some other items that are sort of drawn out of this figure based upon the givens. Deal is, though, by step 11, they've proven that triangle FHI is congruent to triangle GIH. So we know that triangle FHI, so FHI, that's this triangle right here. Let's see if I can highlight that. FHI is congruent to triangle GIH. We'll outline that in another color. So GIH. We know these triangles right here are congruent. If we know those triangles are congruent, then we know that the corresponding parts of those congruent triangles are congruent. Therefore, angle FIH, so FIH right there, okay, inside the green triangle is congruent to angle GHI. So that's GHI right over here. Well, why? What's the reason for that statement? CPCTC comes to the rescue every single time. So click your drop down box. I'm going to have to scroll down. CPCTC, wrong one. There we go. Submit. Brilliant. Fantastic. Let's get rid of those annotations real quickly. So now complete the proof that segment WY is perpendicular to segment VX. Well, we know that VW is congruent to XW, and we also know that segment XY is congruent to segment VY. Those are givens. Then we get some other items here, reflexive property of congruence. We've got side, side, side. We've got two triangles that are congruent. Triangle VWY is congruent to triangle XWY. Also, CPCTC allows us to show that those angles are congruent that are listed there. And then we actually are able to prove that some other triangles are congruent. We've got SAS showing that VWZ, so that's VWZ, the small triangle here, is congruent to this other small triangle, WZX. Now we know that angles that form a linear pair sum to 180 degrees. We've got that here, and then we also have substitution. Because we knew that these triangles, or excuse me, these angles were congruent, we can substitute one for the other. Okay, so we know that these two angles are congruent, so the measure of angle WZX, well, we can substitute the measure of angle VZW. Notice we just place that in from here to here. All right, because of that algebra, we've got two angles, the same angles, equal to 180 degrees. You can kind of think about that as 2x, or your favorite variable really. 2x equals 180 degrees. Well, what happens when I divide both sides by 2? Well, x is equal to 90 degrees. That's how they went from step 10 to step 11. If I have two angles and they're the same angle, well, I know that they must have the same measure. Well, what's the only way to have two angles of the same measure that add up to 180 degrees? Well, they must be 90-degree angles. And if I have an angle that is equal to 90 degrees, then I know that the segments, or the rays, or whatever, line, could be lines, but the line segments in this case, if they intersect at a 90-degree angle, I know that they're perpendicular. All right, and so that's the definition of perpendicular lines right there. All right, so we're going to go ahead and submit that. Terrific. Fantastic. All right, let's jump ahead. So this is sort of the flow. This is how things should go for you in the beginning. We're going to jump a level here. Let's jump up to, once you get to a SMART score of about 60, then you've got to do something a little different. So let's see what's going on here. We know that, I'm going to go ahead and annotate this guy. We know that, there we go. We know that angle TSV right here is congruent to angle TUV. So those are congruent. And we also know, let's grab a different color here, we know that angle STU, so we have STU, this angle here, is congruent to angle SVU. That's over here. So these opposite angles within this quadrilateral are congruent. Complete the proof that shows that segment TU is parallel to segment SV. Well, we've got two givens. Great. Check, check. Now, these are angles within a quadrilateral, so that we know that when we sum these angles up, they must equal 360 degrees. That's our quadrilateral angle sum theorem, similar to our triangle sum theorem, angle sum theorem, which says that all the angles of a triangle add up to 180 degrees. We also have a quadrilateral angle sum theorem. It says that all the angles in a quadrilateral sum up to 360 degrees. Now, if you notice, we did a quick little substitution here. Quick little substitution. The only these two angles, same, didn't change. But because of the congruence up here, we subbed TSV, the measure of angle TSV, for the measure of angle TUV. Notice we've got TSV listed twice now. Okay, that's interesting. And then I subbed the measure of angle STU for the measure of angle SVU because they're congruent. We said that they were congruent up in those earlier steps. So notice that I now have these angles written twice, and much like in the last situation, if I were to say maybe let X represent the measure of angle TSV and let maybe Y represent the measure of angle STU, I've got a situation like 2X plus 2Y equals 360 degrees. Well, notice everything could be divided by 2 if I wanted. So I've got X plus Y equal to 180 degrees. So notice that because these angles are doubled up, if you will, I can divide everything by 2 and I get the measure of angle TSV plus the measure of angle STU equals 180 degrees. What's going on there? Well, that's just simply algebra. Okay, that's simply algebra. And because the measure of angle TSV, all right, plus the measure of angle STU, all right, measure of angle STU. So we've got measure of angle TSV and STU. Because these angles on the same side of this quadrilateral add up to 180 degrees, we've got the converse of the same side interior angles theorem, which says that those lines must be parallel. Those lines must be parallel if on the same side of this quadrilateral here, interior of this quadrilateral, if they add up to 180 degrees, then these lines TU and SV must be parallel. So let's go ahead and submit this guy. And correct. Fantastic. Fantastic. Let's get rid of our annotations. Notice they'll just kind of up the ante on you a little bit, and you got to answer 3 of these things rather than just 1 or 2. Let's jump up a level though. Now we've got to do an entire proof. So let's see if we can do this entire proof together very quickly. Let's see if we can do the entire proof. I love to annotate. I hope that you are trying to annotate either whether it's on your computer or tablet or phone, or if you're just jotting down a picture of this. Just take the picture of this guy, write it down on a sheet of paper, draw that, and then you can annotate it. And it makes this a lot easier, I promise. So segment SV is congruent to segment. So segment SV is congruent to segment TU. So we got TU right there. SV, TU. And then ST is congruent to, I'll do 2 markings, also do it in a different color here for you, is congruent to UV. All right, complete the proof that says that ST is parallel to UV. Well, we're given some things in the beginning, so SV is congruent. Let's select given. That's how you're going to start off your proof 99.9 times out of 100, okay? Your proof's going to start with your givens. All right, segment ST is congruent to segment UV. That was also given, so select given. And then SU is congruent to SU. Well, we've seen that multiple times in previous proofs. When we say that something is congruent to itself, that's the reflexive property of, you got it, congruence. Okay, reflexive property of congruence. Make sure you select congruence, not equality. We're dealing with the segment congruent to a segment, not the measure equal to a measure. If we said the measure of SU is equal to the measure of SU, that would be the reflexive property of equality. In this case, we're talking about congruence. Well, take a look here. We've got SU is equal to SU, and then I've got side, side, angle, or angle, side, side. Well, I don't know about that. What's going on here? What can we use to prove that these angles are, or excuse me, these triangles are congruent? So let's take a quick look here. We've got side, side, side. We're looking at angle, or excuse me, triangle SUV. So SUV right here. And then we're looking at triangle UST. UST. Oh, that looks like side, side, side. Side, side, side congruence. These triangles are congruent because corresponding sides are congruent. So that looks like side, side, side congruence theorem. Now, because I've proven these triangles to be congruent using the side, side, side congruence theorem, I can say that angle SUV, so angle SUV right here, is congruent to angle TSU. TSU, these are congruent. Why is that the case? Because this triangle, this overarching triangle, I'm going to outline that one. This triangle here is congruent to, let's pick a different color. There we go. Congruent to this triangle right here. So we've proven those triangles congruent, and now what are we saying? Let me highlight this in another color so you can see it. Make it stand out. We're saying this angle here is congruent to this angle here. Why? CP/CTC. 9 times out of 10, you're going to follow up one of your triangle congruence theorems with a CP/CTC so that you can use that information to prove these, in this case, these lines to be parallel. Look at what we've got going on here. We've got this angle congruent to this angle. Look at UV. Look at ST. Wow, that looks a lot like parallel lines. That's what we were trying to prove. Why? The converse of the alternate interior angles theorem. We've got these segments with this transversal segment, and I know that these angles within those segments on opposite sides of the transversal are congruent. Because I know those alternate interior angles are congruent, I can use the converse of the alternate interior angles theorem to prove that the lines are parallel. You're sort of working backwards. Usually, we approach a problem and say the lines are parallel, therefore the angles are congruent. But in this case, I've proven the angles to be congruent, the alternate interior angles congruent, and now therefore by the converse of the alternate interior angles theorem, I can say the lines must therefore be parallel. So let's submit this, see how we did together. Fantastic, good work, good work. Now, you notice we've jumped up in SMART score. I'm running out of time. Basically, what you're going to have to do once you get to this level is you're going to have to write some statements. And we've shown that in some previous videos. If you need help with that, please email me. Send me a message on Remind. I can walk you through writing a statement and giving a reason. But this is very similar to what I showed you in M8, M9, as well as N.13. I hope this video helps you be successful on standard N.14 in geometry. Talk to you later, geometry students.